This is the first video in our series on how to factor. We're going to start off with basic GCF. So we're going to factor out a GCF. That means greatest common factor, which are these examples down below. But in order to get a really good understanding on how to factor out a GCF and what it means to factor out a GCF, I want to do a little warm-up problem first up here. Factoring is the opposite of multiplying. So for the problem up above, we're going to actually multiply. We're distributing that 3 inside the parentheses. That gets us 15x minus 24. That's the final answer when we distribute, when we multiply. But factoring, like I said, is the total opposite. So our original question is going to look like this, but looking at our warm-up up here, well, that was our answer. So if this is going to be our question from now on in this little series, that means our answer is going to look something like this. So it's almost like working backwards. So that does make it a little bit challenging. But it's all about understanding what is a factor. Well, factors are numbers that divide into bigger numbers, or numbers that multiply to get your product. So if I want to know the greatest factor that these two numbers have in common, I would say it is 3. I know 5 is another large factor of 15, but 5 cannot divide into 24. And there is no other number other than 1 in 24 that can divide into 15. So our GCF for these two is going to be 3. So when we're factoring out a GCF, our GCF always goes on the outside, and then we're going to end up with a set of parentheses. That's the next thing that we put. So our goal now is to figure out how, and looking back at our warm-up question, we need to figure out how to get these numbers on the inside of our parentheses. How do we do it? Mathematically, how does it work? Well, think about, again, what I said. Multiplying and factoring are opposites. So if we are factoring, what is the opposite of multiplying? Well, typically, it's dividing. So what we're going to do to get what's on the inside of the parentheses is we're going to divide each term by our GCF. And when we divide each term by our GCF, we get 5x minus 8, which coincidentally ends up being the original question to our warm-up. So here's a second example we have here. We're going to factor 2x squared minus 14x, and we're going to do that by finding the GCF. So we got to find the greatest common factor that divides into 2 and 14. We're going to focus on the numbers first. And because they're both evens, I'm going to say that 2 is part of the GCF. But it goes a little bit deeper than that because we have variables in both of these numbers. So if you want to know what they have in common, you're going to look at the variables that they have in common. They both have an x in common. So I know I'm going to put an x there. Technically, this x has an exponent of 1. And I know that when I divide my exponents, when I divide my variables, I actually subtract my exponents. So I'm going to look at the smaller of the two exponents. So here I have an exponent of 2, and here I have an exponent of 1. And 2x to the first power actually ends up being my GCF. So I'm going to factor a 2x out of this binomial right here. And just like in the previous example, we said the opposite of factoring is multiplying. The opposite of multiplying is dividing. So when we factor this out, we're actually going to divide each term by the GCF, and that's going to get us our final answer. So we have 2x squared divided by 2x. The 2's cancel out. X squared divided by x just gives me x, because when we divide, we subtract the exponents. Minus 14 divided by 2 is 7. X divided by x cancels out. And this ends up getting us our final answer in factored form. So to summarize, to review, and I'll go ahead and review this in a more colorful way here.